Awesome. All right, guys, it's Dominic here for KitGuru, and today I am lucky enough to be joined by Mr. Frank Azor. So, Frank, first of all, how are you doing?
I'm doing well as we can be doing, considering the current circumstances around the world, but doing well. Thank you. How are you doing?
Yeah, very good. Thanks. Very good. It's great to be able to chat with you like this, even if we can't meet up in person. I'm sure there would have been various launches over the last year or so where we could have got together and do this in person, but no, good to be doing it online. Just for those who don't know, Frank, I'm going to ask you, what is your official role at AMD? And can you give us any examples of what you'd be responsible for during your time at the company?
Yeah, happy to. So, by title, I'm the Chief Architect of Gaming Solutions. But AMD is still relatively a small enough company that everybody wears a lot of hats. The lines of what everybody does are kind of a little bit soft, I would say. Everyone's kind of working together, trying to help push the company forward in everything that we do. But I spend most of my time with our gaming marketing team, helping us generate awareness around our new products and technologies. I've also spent a lot of time with our software product management and product marketing teams. So we just launched our latest software, Big Bang 7, as we refer to it internally, right? The Adrenaline 2021 version. So spent a lot of time defining, designing that software build, and helping bring it to market last week. And then I also have been creating an initiative here at the company where we call it A+A+A, or AMD CPUs, AMD GPUs, and AMD software all working together to create a better computing experience than if they were working individually. So I've been leading those key initiatives for us here since I joined in July of 2019.
Awesome. I think that kind of A+A+A is what I really want to focus on today, because I think it'd be fair to say AMD is kind of in this unique position where it can make the high-end CPUs and can make the high-end GPUs, but nobody else really does that. Obviously, we have Intel, who's looking to get into the GPU space as well, but at the moment, if you want to buy, a new CPU and a new GPU to put in your computer right now, if you want both of them from the same company, it's only going to be AMD. Just going back, I know you were previously at Alienware as well. Can you tell us anything about how your time at Alienware has informed what you do at AMD and kind of how that background has played into your role?
Yeah, it's actually very interesting because even though my time at Alienware and Dell, I was a customer of AMD's the entire time that I was there, over 20 years. I was living in a different world completely. You're on the receiving end of the silicon, the CPU and the graphics silicon and the drivers and the software. And you're typically focused as an OEM or as a system builder on what are you going to do with that silicon once you receive it and that software, and how are you building a solution, a laptop, a desktop, or any other form factor in between that makes use of the performance of that silicon, but really focuses on a lot of different attributes of the customer experience, like noise and thermals and the front of screen experience or the display experience, battery life, so on and so forth. So all of my experience is in the actual end user customer experience of the laptop or the desktop. When I came to AMD, and this is one of the reasons why I came here, it's because I didn't have any experience on the silicon side of the world. I had been a customer of it for 20 years, but I really didn't understand what went into making CPUs and graphics, and I'm still learning. I still, by all means, don't understand it, but I'm learning so much. And what was really fascinating to me about the opportunity is the ability to actually influence what goes into making those CPUs and those graphics and making that software, and how a lot of the innovative ideas that we came up with over the years at Alienware, they were somewhat constrained in that where we could implement those ideas were constrained to the mechanicals and the electricals of the notebook or the desktop. We couldn't really have a lot of success in changing the path of CPUs and graphics. And coming here, that was an incredible opportunity. It's very, very exciting. The other thing that's really interesting is because of my background, it's a very different background than what most people at AMD come from. They usually come from the silicon space, and they've been building chips or designing chips or working in the semiconductor industry their entire lives. And I'm a bit of a foreign entity here in that I come in and I don't speak the same language. I sit in a lot of meetings and they're talking about silicon design and things, and I'm just like, my head is spinning. I don't understand a lot of it. But then at the same time, I come in and I start talking about the end user experience, and I start giving some perspective as a customer of AMD's for 20 years. And it's making a big difference in some of the things that we're doing and how we're planning and how we're approaching our roadmaps, our launches, our customers. So it's a little uncomfortable, but it's really I think exciting for everybody that's involved, because we're both learning so much. And I mean, look at what we've accomplished in just the year, almost 2 years that I've been here. We've done a lot of really cool things: SmartShift, Smart Access Memory, and we have so much more coming so soon that I think the impact is going to be really felt in a big way.
I like the sound of that. Yeah. So, well, you mentioned Smart Access Memory there. That's kind of the first of these big ideas I kind of want to get onto.
Okay.
So first of all, you mentioned there that you're in your role at AMD, you've been able to kind of come up with these more innovative CPU to GPU solutions, and I guess that is where Sam would come in. So, from just a kind of definition perspective, we know that resizable bar has been part of the PCIe spec for a while, but then it was only October, November last year we first started hearing Smart Access Memory resizable bar. Are they the same thing? Is Smart Access Memory just AMD's fancy name for resizable bar, or is there more to the story?
That would be a stroke of marketing genius if they were the same thing, wouldn't it? No, they're not the same exact thing, and that's where there's a lot of confusion. And some of our competitors want you to believe that they're the same exact thing because they want to try and devalue all the work that we've done with Smart Access Memory. The key thing to remember is that Smart Access Memory makes use of rebar, readdressable bar. But they are not one-to-one synonymous with one another. What we did is we were early adopters of rebar, and because of the benefits of having CPU and GPU all under the same company, we took advantage of that to really optimize the heck out of the feature, so that we can get the best performance out of leveraging the rebar capability, the PCI Express spec. And that's what primarily the difference is. So it's like, we all were given the same tools, but how we use them delivered a different result. We are able to apply the tool more effectively and efficiently because we have both CPU and GPU under the same company, under the same umbrella. I mean, it is as simple as people exchanging emails with one another, picking up the phone, having an instant message dialogue. Typically when two separate companies are interfacing with one another, the interfacing tends to be very different. There's a lot of preparation for a discussion and a meeting. You have maybe a once a week meeting that you're doing, a kind of a core team meeting for an hour a week. There's a lot of filtering as to what can we share, what can't we share. All these rules and challenges and obstacles that go into things. And quite honestly, it's suboptimal to what we have been able to prove we can do with Smart Access Memory, for example, because everything's under the same umbrella. So when you look at the performance of Smart Access Memory, you're seeing that the performance is not on par with other rebar implementations that are out there. We're way above them. I mean, we're delivering double-digit performance gains in several titles out there, and I think the best case scenario for other implementations is like 4, 5, or 6%. That's the result of A+A+A in action. That's the customer benefit. I mean, just absolutely demonstrating itself. And that, probably the best thing about it is it's virtually free. Like, think about how much investment you have to put in as a consumer to get 5 or 10 or 15% more performance out of a CPU or a GPU. Typically, you have to bin up. You have to move up a bin in those components. You got to spend 50, 100, 150, 200 plus dollars to get that kind of performance, and you're getting it basically for free with smart access memory. That's what's, in my opinion, like transformative is, and it's the first true, outside of SmartShift, which also has some major benefits, of course, but it's the first kind of benefit for desktop customers, and the one that really shows the power of A+A+A in action.
Can you, because we know we have seen the games for ourselves, can you talk a bit to why certain games might be seeing negative scaling? I know there's a few examples where, you know, some games are plus 20%, others might be minus 10%, for instance. Can you explain as to why that might be happening? Is it just up to the game developers to kind of optimize a bit more now that smart access memory is a thing? Or is it something else more fundamental?
No, it's not anything more fundamental. It's just it's something that we didn't have before. And what some games did is they optimized really well to the 256 megabyte limitation that we had before. We put rebar and smart access memory in place, and they never really accounted for the ability for that to increase. So they didn't really have like a flexible architecture in their code and things. So we've kind of introduced now this not unpredictable, but I would say this unanticipated capability. And it's a little bit of a random what happens type of scenario. Some games are making use of it, and it's going, you know, maybe they anticipated it, maybe they didn't, but just the way that the games are developed, they naturally are scaling well. And then some other games are kind of like, what the heck is this? I don't know what to do with this. So they have, you know, detrimental performance. So that's why we're not turning it on for everybody 100% of the time, where you have the ability to turn it on and off. And there's other things we're doing with smart access memory. We're not at the end of it by any means. We're going to continue to improve it and improve it. We've integrated it into all of our ISV and game testing as well. So whilst we're bringing up games and testing them on our CPUs and GPUs, which we're always doing, we're constantly coming out with new drivers as well, you know, day zero patches and things, or day zero drivers for games and things. Smart access memory is integrated into that, and that's allowing us to detect those performance detriments early, work with the ISVs so that they can be improved upon before the game comes out to market. But it's kind of hard to do that with games that were launched years ago. You know, some of those companies aren't even in business anymore, so we don't have contacts for those games. And then the other situation can oftentimes be that they've moved on to more current or future projects, and they don't have a team that's able to go into the game to optimize it for smart access memory. So over time, that'll kind of diminish more and more as more new games come out and they optimize for it. But right now we're in a situation where it's amazing for some games and it's not so great for others. You know, the 10% performance degradation you referred to, though, I don't know if I don't think I've seen that much of a performance degradation, or if it does happen, it's like a weird exception of a game. It's certainly in an ultra minority. I think the games that do tend to get degraded in performance are more in the single digit numbers, but we see a lot more games benefiting from it than hurting from it.
Yeah, and one of those games, I think, definitely the game I've seen the biggest gains from smart access memory would be Assassin's Creed Valhalla. And I know that was obviously a game AMD was involved in the development process. When you launch the game, you know, you see the AMD logo flash up. Is that something you were able to build into the game as it was coming? You kind of let them know, hey guys, we're going to have this thing. Here's how you can maybe benefit from it most. Or did it kind of just happen naturally? It just happened. It was one of those games where, you know, having access to more than that 256 megabyte chunk just happened to help.
Yeah, I don't honestly know. I'm not involved on a per game basis, like exactly what there's just too many games out there, right? So I'd have to ask our ISV team what the history is on the title. I'm not entirely sure, but typically when we have partner games like that, you know, they get to see our technologies early. Okay. And, you know, we're showing them what's coming in the future, 6 months, a year plus down the road. So they probably had more time to optimize for it than folks that aren't in our partnership program. So it's really, you know, important that game developers reach out to our ISV team, and they understand and they build a relationship and a partnership program with them so that they understand what's coming, because things are moving faster than ever right now. Now that there's really fierce competition from us in CPUs and in graphics, the rate of innovation is increasing. You see it, right? You see how exciting have things been in the last couple of years, especially in CPU, and now with RDNA 2 being as competitive as it is in graphics, you're going to see this accelerated rate of us and our competitors all trying to one up each other. And what's really cool about where we're at right now is historically we all did that by just pumping more raw performance into the SoCs for CPU and GPU, and it was like, how much can you afford to put in there, based on your process shrinking and your cost goals and all these different things. But it was primarily like a hardware and an architecture battle that we were in. And now software and these other tactics are playing a much larger role. Like we just talked about, smart access memory, 5, 10, 15% performance improvement. No incremental raw horsepower was built into the silicon to be able to deliver that. This was a very smart approach, a more efficient, a more optimized approach to increasing performance outside of just throwing more horsepower at it. So as these opportunities continue to present themselves, the competitiveness is just getting that much more fierce. So if you're a game developer, you can, and you're not in tune and in touch with us and our efforts, you can really get kind of left behind on everything that's emerging at the rate in which it's emerging here in the future. So it's a really good opportunity for those relationships to strengthen. And I encourage any game developers out there to reach out to our ISV team and just, make sure you understand everything that's coming down the pike from us, because there's an enormous amount of innovation coming. And the whole A+A+A strategy is kind of new. We've never had something like that before, or the industry hasn't had anything like that before. Our competitors are trying to catch up to that strategy that we have. And the opportunities there are enormous, way beyond even what we've shown with smart access memory or smart shift. And again, if ISVs understand it's coming, they take advantage of it, you'll be able to see huge performance gains with their games because they optimize to it.
Yeah. You raised an interesting point there that it's only a recent thing you've had this new strategy, but obviously AMD's been making CPU and GPUs for a long time. Can you talk to why it's only recently we've started to see this focus on the two components together and like the whole system approach?
Yeah, it's a good question. It's interesting. It's a long answer, so let me try and shorten it.
Wicked.
What's interesting is that the idea of A+A+A is not brand new at AMD. Actually, if you think about AMD acquiring ATI, the APU, or otherwise known as the CPU with integrated graphics, after that acquisition, that was really the first A+A technology that AMD produced. They took Radeon graphics and integrated it into the CPU to build the APU. But then there was a long period after that, and I wasn't here for that at AMD, but as a customer, we kind of witnessed that on the sidelines, and it was a very challenging integration. I think anybody at AMD would tell you that. But what that did is it took years, it took a lot of practice, it took a lot of process engineering, and what that did is it paved the way for us to be able to do what we're doing right now with A+A+A. We added software as the third A, and we're able to do the things that we're able to do right now because those bonds between the CPU team and the graphics team were formed for us to be able to enable that to happen. But prior to Zen 1, honestly, AMD had other challenges. It had to get a competitive CPU and it had to get a competitive GPU. And the priority for the company was to do just that. And honestly, before you have those two things, an A+A+A strategy like we're executing right now probably doesn't make the most sense to spend your resources on, because it's just you kind of have to have one or both of those things be competitive first and foremost, and then you can build on top of it for it to make sense. So the timing of everything, it's really worked out kind of perfectly. We had the ATI acquisition. We had the team work together to integrate CPU and GPU to build the first APUs from AMD. That set the framework for everything that we're doing now. We had Zen 1 launch with everyone, which everyone said, wow, Zen 1 is pretty good. We had Zen 2 launch, everyone said, wow, this is pretty great. And then we had Zen 3 launch, and then RDNA 2 shortly thereafter, and the world's like, wow, this is really amazing. Right on top of that, you start building A+A+A, and it starts to really solidify our position in the market as the market leader. And those are the benefits we're reaping right now.
Excellent. Okay, so we'll kind of leave SmartX memory to the side for now, but the other one you already mentioned is going to be SmartShift. This was, correct me if I'm wrong, this was announced at CES 2020. Can you tell us just generally what is this technology and how it works?
Yeah. So, thermal and power shifting is not something that's brand new to our industry. I can remember working with other companies back when I was at Alienware, maybe over a decade ago, to do the same exact thing. We were shifting power from the CPU over to discrete graphics so that we can do a smaller footprint notebook. And when GPU workloads, graphics workloads were in most demand, we would shift that power over. So that's been occurring for a long time now. And implementations were put in place a while ago, hybrid graphics and power shifting and all these things, but they really haven't been focused on in a long time. I mean, they were almost a decade old, most of these technologies. And it's kind of been left up to the OEMs, Dell, Lenovo, HPs, and so on of the world to really do the rest of the platform optimization themselves by and large. And we saw that as an opportunity to take a more modern approach to how we do power shifting between the CPU and the GPU, or the APU and the GPU, and to take advantage of the fact that we are both an APU company and a graphics company. And a lot of this work actually predates me joining the company. When I was at Dell, I was actually a customer of SmartShift because we put it into the Dell G5 15-inch product, the SE. And then I came over to AMD and kind of picked up where the team had been working on that and helped bring it to market, so on and so forth. But the primary difference is we are able to do it at a hardware level, deeply rooted into the architecture and the design of the silicon. And the reason that that's beneficial versus other thermal shifting and power shifting implementations is, one, it's very fast. It's extremely low latency because we do it at a hardware-based level. And we have an enormous amount of experience doing that because we've been doing it in APUs, right? You have graphics in an APU and you have the CPU cores in an APU. And for years now, AMD's been shifting power between them within an APU. All we basically did is we took that logic and that core and we said, let's apply that to discrete graphics now. So the efficiency and the power and the low latency of that is now applicable to discrete graphics. If you think about any other discrete graphics solution that's out there in the market today, any really competitive one, they don't have the experience of building those x86 APUs and that integrated graphics. So they're having to rely on partnerships with us or our competitor on the CPU side. And they also have a bias, which we don't have. Naturally, if you're the CPU, you typically want as much compute to be done on the CPU as possible so that you're more relevant in the platform. And if you're the GPU, you want to do that. We don't have a bias. So we can go bidirectionally in our power shifting. So if the CPU workload is intense, we steal power from the GPU and apply it to the CPU and give you much greater CPU performance. And then inversely, if you're running a game or a workstation creative type application and the GPU workload, the graphics workload is intense, we steal power from the CPU. And then what we do is we're constantly monitoring to make sure, we didn't steal too much power and it's actually degrading the performance. And if we did, we shift it a little bit back and we constantly better balance it. So it's as optimized as possible versus it kind of being what I would say with other solutions, it's more of a we're shifting power, set it and forget it type of model. We're constantly going back and forth.
Right. Okay.
And at the fundamental hardware level, there's no drivers, there's no software requirements, there's no OS interfacing. The OEM has a lot less burden on them as well. They don't have to worry about all of this. They help us design a shared thermal solution, and then we test and we optimize for it. But all of that work and burden is on us to go optimize that within their platform, which makes it easier for them. And we're centralizing the expertise all at AMD. So as we learn things from platform to platform, we're able to optimize it further and further and further. And it's paying dividends for us. I mean, we have an incredible solution with SmartShift.
Yeah, no, I wonder, you mentioned the OEMs there, and I just wanted to pick up on that point because everything you said sounds absolutely brilliant. It's like fundamentally, it's just a good idea, isn't it? But it doesn't feel like we've been hearing that much about it. I don't actually know how many laptops out there currently actually support SmartShift. So I don't know if you can share that information with us or how we can try and get this technology into more machines going forward.
Yeah, the thing to remember about notebooks is that things take longer in notebooks because notebooks are typically developed in about 52 or so weeks from when you start kind of real development and then you actually launch the product. Because within that you have your shipping and you have validation and testing. I mean, your actual detailed development is maybe 30 weeks of it, or 35, 36 weeks. But then you have all the other things on the ends of it, like validation, testing, shipping, all those kind of things. Before you ever begin development, before you do your detailed development start or your detailed design start, there's about a year of planning that goes into a notebook, where you're looking at all these inputs around what are the market conditions, what do customers want from that our research tells us, what are the roadmaps telling us is coming in this time frame, so on and so forth. So it's really the things that we're talking to partners about today, right now, that's new and cutting edge, that you're really not going to see in notebooks until maybe a year and a half to 2 years from now. So because of that lag, that's what you're experiencing with SmartShift. SmartShift was or is a technology that was brand new. It was cutting edge. We had to figure out how to do it and do it well. So we partnered with Dell to go do it. And we had to prove out that it worked as we intended it to work before we went out to a bunch of different customers and said, look at this amazing thing. In theory, it works, and this is how well it works. That's hard for another customer to come in and jump in with you 100% on. So the strategy was, hey, let's go get one platform. Let's work on it with them. Let's go make sure this thing works. Let's show people that it works really well. And from there, if we're successful, we're going to get much more rapid adoption. That's where we're at right now. So we have already announced that you're going to see us introduce Navi in mobile this year. We've talked about that at CES. When you see us do that, you will see several more solutions coming to market with SmartShift and everything I just talked about materializing.
Brilliant. Now I look forward to testing that. Another thing you mentioned there, I just want to pick up on. You said when you've got this new thing or this new technology, it's not always easy to convince the OEMs to jump in with you. But what we're seeing now with the Ryzen 5000 mobile series, it seems like a lot more of the big players are basing more models, at least, on these new SKUs. Would you say that Ryzen 5000 is kind of been a turning point for AMD in the mobile space, where we saw a few good systems with Ryzen 4000, but now it seems like there's been a bit of a turning point and people are kind of saying, oh yeah, hold on a minute, AMD's got some good stuff in the mobile space. Why don't we do a few more of their machines?
Yeah, that's exactly it, right? We got a lot of comments about when Ryzen 4000 series launched, everyone realized this is an amazing APU. It's not just incredible in performance, but it has exceptional battery life and power efficiency as well. But you only saw, not a handful, because there was over 100 notebooks out there, but folks were giving us feedback like, why aren't we seeing this APU in this system and that system and that system? And it's exactly what I just talked about. You have some OEMs that kind of take a risk with you and they jump in with you, and you see, and they'll do that with some of their SKUs, and that's what we saw with Ryzen 4000. And those that did that, they benefited from it because the demand for the product was enormous, right? And then you have other folks that kind of look at the market and they look at the successes of the past, and then they plan their portfolio in the future based on what's happened in the past. So I would say technically and performance-wise, Ryzen 4000 was that inflection point where people really realized we can build the best APU in the industry. And then what Ryzen 5000 does is it says, okay, here's the massive adoption of the APU or of an AMD APU. Let's start assorting it everywhere where high performance and great power efficiency is important. And you're seeing much more adoption and many more designs taking Ryzen 5000 because of that. But Ryzen 4000 was and still is an incredible APU. What an incredible accomplishment for the company.
Brilliant. So that's kind of, we've talked CPU and GPU. You mentioned the third A then is software. So what was it? Was it last week or was it 2 weeks ago? With the latest.
Yeah, I'm losing track too. I think it was last week, but they all the weeks kind of blend together at this point during COVID.
Okay, so let's go. It was last week then. Adrenaline 2021, the big update came out. Can you remind us what's new if you have a Radeon GPU?
Yeah, absolutely. So I think it was last week. I'm pretty sure it was last week. We introduced 2021 and several new things. One thing is we simplified the user experience. So we got a lot of feedback from customers. We introduced the new user experience, I think, the year prior to that. And there are a lot of things people loved about it, a few opportunities for improvement. So we incorporated a lot of those opportunities for improvement into this. One of those things that we did is we really only had like a full installation option before. It's like, here's the big package, and that's all you can install if you want to install Radeon drivers. We now have a minimal installation option as well, and a driver-only installation option. You're going to miss out on some of the best features that we have, and a lot of these are performance features and things if you go with the driver-only install, but customers said they wanted that, so we made that available. So you have a driver-only install, you have a minimal or simplified installation, and then you have the full package as well. So that's one of the key features that people love. The other key feature is we integrated some of the Ryzen CPU monitoring tools and capabilities that have typically been reserved exclusively with our Ryzen Master software, which is a separate software if you have a Ryzen CPU. We brought some of those features into our Radeon software. So Radeon for a long time now has had GPU and VRAM monitoring tools and metrics and logging built into it. So you can see how your GPU is performing in the system, how much power it's consuming, how much it's being utilized, how much of your VRAM is being utilized. Well, now you can do that with Ryzen as well. So you have a unified user interface, so you can see everything going on between your CPU and your GPU. Again, A+A+A working together right there perfectly, where we're looking at the entire solution as a platform and trying to give you a unified, simplified customer experience. We've also made several improvements to our recording and streaming capabilities. So we have a new wizard in there that makes things easier for you. We also simplified the entire end user experience, and so that you can just press one button and basically stream whatever you're playing or whatever you want to stream to your favorite social media sites out there. We have a lot of support for a bunch of different sites around the world as well. So it's not just YouTube or Twitch. We have some of the Chinese local sites as well and others. And this is not intended to be like an OBS replacement by any means. This is not a professional streaming solution by any means. This streaming solution is intended to just, if you do it occasionally or a buddy asks you, hey, I want to check out your game stream or something like that, and you want to let them spectate you for whatever reason, or you're trying to teach somebody how a walkthrough or something within a game, you can just turn this on real quick. It's built in. You don't have to download another piece of software. You don't have to learn a new interface. You don't have to do any of those things. It's kind of like click and go solution. And then if you want to get into something more professional, by all means, get OBS or get any of the other streaming solutions that are out there. We're not trying to compete with that. On the contrary, we're trying to get people comfortable with streaming by giving them an easy, unintimidating user experience, hoping that they'll graduate from this into one of those more professional solutions. We also implemented some color deficiency solutions. So if you have different types of color blindness issues that are out there, you have settings now that can help adjust the experience for you to be able to compensate for that. And then we did something really cool. We introduced something called Crash Defender. So, look, we've all been, if you've been using PCs for a long time, you know that it's never 100% perfect. There's always bugs. There's always some issues that come up. And we've worked really hard to make the Radeon software much more reliable. It's really in an incredible place right now where people are really loving it, and it's been very stable, very reliable. All the latest drivers that we've been releasing. But when things go wrong, and sometimes they do, inevitably, it's an open platform, the PC, right? There's a lot of unpredictable things that happen in an open platform. What we've done is we put Crash Defender in there. So think of it as like a stay alive or like a safe mode for your graphics driver. So if things are going wrong, we revert back to that mode so you can save things, you can recover your work and everything, and then you just restart and go back into a healthy state of the full driver package. So it's like a fail-safe mode, if you will, in case things are going wrong. And then the last thing I'll share with you about the new software is we made a huge update to AMD Link. If you're not familiar with AMD Link, what it does is it allows you to basically turn your Radeon powered system into like a home server. So you can, using your smartphone, both iOS and Android, even some smart TVs out there, you can download a client for them and access your home Radeon server using AMD Link. You can play games, you can get you can run apps, you can do different things like that. So imagine it like your own personal cloud server. And what we've introduced with this feature is a new Windows to Windows streaming capability. So if you have another Windows Radeon PC, you can access your Radeon server, and you can do very high performance game streaming. So 144 frames per second, 5.1 surround sound audio. The latency is very low, very efficient as well. So it's a major improvement to AMD Link. It's been around for a while, but we haven't had the Windows to Windows streaming with all these high performance options before of like 144. So that's the other major update.
Brilliant. And I'm sure you get asked this a lot, Frank, but I know if I don't ask you, people will be asking me why I didn't ask you. So can you share any more details or any more updates at the moment about FidelityFX Super Resolution? I know it's a feature a lot of people are very interested in, and it wasn't part of the big update. So anything else you can tell us would be awesome.
There's not much I can tell you, except I'll tell you that it's real, and okay. we are making steady progress on it. We are going to have a solution this year.
Brilliant.
And what I'll tell you is our approach to super resolution or upscaling, it's going to be different than other upscaling solutions that you see out there. And we want to make sure that when we come out with a solution that it's going to be high performance, it's going to have very good image quality, and that it's going to satisfy customers and that they're going to be happy with it. We also look at other solutions that are out there, and we're really cognizant of what their advantages are, but also what their disadvantages are. And we're trying to build a better solution, and that takes time to do that. Copying what's already been done out there before is the easiest path, and we're not doing that. We're doing our own solution. We believe we have a very compelling value proposition. We think gamers are going to be happy with what we're going to be bringing to market. And like I said, it's real. It's coming, and people won't have to wait that much longer for more news on it.
Excellent.
That's all I can say right now.
I like the sound of that. Not waiting much longer. That's brilliant. Okay, Frank. Well, I'm going to let you go there. I know you've got to go off and do some things. I just want to say a big thank you. It's been great talking with you. I'm really looking forward to testing out Super Resolution myself and seeing what that's going to be like. So thank you for your time. All the best for the rest of the year, and hopefully it won't be too long before there'll be a certain AMD event and we can meet in person. But Mr. Frank Azor, thank you very much.
Thank you, Dominic. Great talking to you.